Okay, so now I'm going to come back to this bracket here. And I'm going to put some datums on this so that we can start talking about some more GD&Ts. Oops. So now I'm just going to leave it set to datum. I'm going to call this A. Sorry, call this A. Add that feature. Okay. Okay. Add another datum. Pick that surface. Okay. Okay. Add one more datum. Okay. Now you can see I have datums A, B, and C, but I want to, put some pre-qualifiers on it, and I want to tolerance something back to a datum reference frame. So I can go into any one of these, and I can click on the datum reference frame tab, and you can see these are the features that I have. So I want a datum reference frame that is A and B, so I will add that. And I want another datum reference frame that's full blown. Delete A, B, and C. Now I have two datum reference frames. So with that, I'm going to go ahead and I'm in my rocker, right? Yeah. So now I'm going to add a perpendicularity tolerance. On this feature here. 1 millimeter. It's a surface, so I don't have a modifier, and I want to go back to just A and B. Okay. Okay. So now you can see this surface is tipping and rocking within its perpendicularity tolerance back to A and B. This surface is deviating with its linear tolerance back to this surface, which is deviating due to a size tolerance on this surface. If I continue on and I say, I want to add a profile tolerance to this surface, back to A, B, and C, 1 millimeter. Now this is where if I do a nominal build, separate, and deviate, you can see that this is moving a lot more than 1 millimeter. This I'm hoping we will ultimately add a validation error that tells you that this surface is double toleranced. It's toleranced 1 millimeter to A, B, and C, and it's toleranced 5 millimeters back to this surface. So you can't do that, and if we can catch it, we'll warn you. What I do want to do, though, is I want to talk about common zone, and I'm going to put a flatness tolerance on these bottom two surfaces. And say, okay. Now, flatness, we know, is a refinement of location and orientation. And you can see those surfaces are deviating for its form control. because we are deviating from nominal, it's essentially treating it like it's a common zone. If you apply flatness to two offset surfaces and you define it as a common zone. Now, if I continue on and I add a profile to that surface, and I pick both of those faces again, and I'm going to make this 10 millimeters. Back to A, B, and C. Okay, so now if you catch it, you can see those are changing in form, but they're definitely not treated as common zone. Okay, so you have to, and this is when I'm training people, with the software, I always say, hey, make your tolerances big, deviate it so that you can see what is it doing. This is an example where if I want to treat that form control as common zone and I have this profile tolerance, I would have to go into my options, and this is where I would want to say group all features for the profile tolerance. Now, when I deviate it, you can see it's still moving within the 10 millimeter tolerance zone, but it's taking both faces with them and they're deviating within that 1 millimeter form zone.